everyone. Today we will discuss reproductive seasonality in horses, namely in the mare. The stallion also has his own gimmicks of seasonality, but we're going to focus on the female here. And we're going to talk about how her reproductive system's level of activity depends on the time of the year. So, the major factor that influences reproductive seasonality is photoperiod, which is the amount or the hours of light, that the mare is subjected to in a day. You could also think of this as the hours of darkness that they are subjected to in a day, but since the eye perceives light through photoreceptors, I have so eloquently drawn this with little squiggly yellow lines here, and here's the eye. So first, the eye must perceive light. So that will tell how long each day is, how much daylight. And this information will be relayed to her brain. Here you see it's going to travel through nerves that are going to synapse upon each other. It's going to go to the suprachiasmatic nucleus. Sorry, drew 1 there. It should have been a 2. And just to take a pause and let you know ahead of time, there's a lot of detail in this chart that I've drawn that we won't really go into in the video, but it's here for accuracy, and it was modeled after a chart from the book Pathways to Pregnancy and Parturition by P.L. Singer. You can find this same chart on page 150 of the book with some added parts that I've given at the end. So mostly what we're going to be talking about is how does the amount of light influence the mare's cyclicity. So we're going to focus most on the gonads, not as much on what all is happening in all the different parts of the hypothalamus, suprachiasmatic nucleus. So with that in mind, let's continue. And so these nerves are going to synapse, and this here, that's a superior cervical ganglion. Again, that's not a detail that we're really going to go into here. And the main point is that this will end up relaying a signal to a part of the brain called the pineal gland. And the pineal gland produces an amino acid derived hormone called melatonin. We've represented that here with some blue dots. So melatonin, there we go. That's step 3. And also, this signal being relayed to the pineal gland will lead to decreased norepinephrine secretion. That's not a detail that we're going to go into, but it is represented here for scientific accuracy. What we're really interested in is this melatonin. So, melatonin is released in high amounts in response to a lot of darkness. Like I said earlier, you could measure how many hours of dark the animal is subjected to, or how many hours of light. And the more hours of dark, so then the less hours of light, the more melatonin will be released. In this situation that I've drawn here, we're modeling a horse that is receiving a lot more light, such as during summertime. So, a lot more light during the day means a lot less dark. That means we're going to get, this is step 5, low melatonin release. Alright, what does this cause? Well, again, some extra detail here. That's going to, the decreased amounts of melatonin released will affect the RFRP neuron. This will increase release of RFRP3, subsequently stimulating the long day KISS neurons. And I'm not able to give more background on the KISS neurons and KISS peptins in this video. However, we often refer to them as the gatekeepers because they control, or again, yeah, they're the gatekeepers of GnRH release from neurons in the hypothalamus. So, what happens if long day kiss neurons are stimulated? Well, oh, I apologize, I forgot a step here. There we go. Long day kiss neurons are stimulated. That means a lot of the neurotransmitter KISS-10 is going to be released. This will result, since these neurons synapse on the neurons that release GnRH, ta-da! Lots of GnRH released, or an increase in it as compared to other times of the year. So, we get a lot of GnRH released, and I'm going to label these as their individual steps, even though the book calls a lot of these step 7. But for clarity of our video, what is going to be the result then of higher levels of GnRH release? Well, you can get more detail on this in the estrous cycle video, but I'm hoping that you have enough background to recognize that release of GnRH will cause an increased release of FSH and LH from the anterior lobe of the pituitary gland. And you can see I've drawn that in red, so to associate what goes with that: ALP, anterior lobe of the pituitary, PLP, posterior lobe, just because unfortunately I've run out of a little space here. And what's going to happen as a result of that? Well, if you increase your release of FSH and LH, what do we use FSH for? What, I guess we should say, the mayor is going to use that FSH for. That's going to allow maturation of follicles in the mare's ovaries, and these follicles can then, that will support them. And then LH, once the follicles have matured to a certain stage of selection, they now will be LH dependent, and they will be able to mature to dominance thanks to this increase of FSH and LH. Also, LH we know is necessary for ovulation to occur, and once ovulation occurs, luteinization, which refers to formation of a corpus luteum from the cells that once comprised a dominant follicle after ovulation. CL, I've abbreviated here, corpus luteum, will form. So, there's that. What does this mean? Well, if the mare is ovulating follicles, those follicles are being luteinized to form a corpus luteum. They will go on to produce progesterone. This means that the mare is in cyclicity because she is able to produce the hormones and the structures in her gonads that will also produce hormones necessary for ovulation of an oocyte that can be fertilized, and then production of progesterone, which is necessary to maintain a pregnancy. So, this return to cyclicity, or this being in cyclicity, traces back to the fact that the mare was perceiving a lot of light, a longer photoperiod. On the flip side, what happens when there are increased hours of darkness or decreased hours of light? Well, the mare's eye will perceive that We call these shorter photoperiods. And we've already been through the more complicated dynamics of it previously. However, just want to go through the process really quick to show an important contrast is that as a result of more darkness, less light, there will be an increase in the release of melatonin. Therefore, there will be a decrease in the release of GnRH. And we know that GnRH is a what we would call a trophic hormone, which means that its release will cause the release of other hormones, in this case, FSH and LH. But since we have more melatonin, we have less release of GnRH because the neurons that release GnRH are being inhibited. So what does this mean? It means that we're going to have a decreased release in FSH, follicle-stimulating hormone, and LH, luteinizing hormone, from the gonadotroph cells in the anterior lobe of the pituitary gland. Now, I want to make clear here that, yes, there is a decrease in the release of FSH, but this is a lot less dramatic. It's not a huge change in the amount of FSH released, because we can see that even during times of the year, for example here, the winter, when there are more hours of dark and less hours of light, that the mare's ovaries will still, you'll still see follicles grow. However, the mare is not in cyclicity because there's a very dramatic decrease in the release of LH, which means that once these follicles reach a certain point in their maturity, a certain point in selection, when they become LH dependent, they are going to be, so to speak, starved of LH and will go into atresia, meaning that they will just kind of degenerate and shrivel away, for more graphic term, I guess. So they'll never fully mature, they'll never reach dominance, will never ovulate, will never undergo luteinization, so a corpus luteum will never form. So that means that the mare is not in cyclicity typically during these times of shorter photoperiod, like the winter. And why is that? Well, to recap really quick, it is because there is such a dramatic decrease in LH that those follicles can never fully mature. They cannot ovulate, they cannot luteinize. So that means that the mare's gonads are not providing what would be needed to sustain a pregnancy, which is progesterone. If we think about a whole year, we know there's not just, of course, winter and summertime, or as we've been referring to them here, times of longer photoperiod and shorter photoperiod. There are also spring and fall, and we will refer to these as transitions because they quite literally are transitions. Vernal transition, here in the green, refers to springtime, and that's a transition from shorter day length to longer day length, so photoperiod is increasing. Fall transition in the fall is a transition from longer day lengths to shorter day lengths, so photoperiod is decreasing. Now, I've created a chart here to kind of help you organize how to recognize what changes will come with each of these times of the year. By anestrus here in the blue, that's going to be winter, and vernal transition and ovulatory here written in red, that's going to represent summer. So the way I've listed the seasons going from winter to fall is starting out with shorter photoperiod, increases, reaches time of maximum photoperiod in the summer, and then the chart ends on the transition back to shorter shorter photoperiod again. So let's fill this out together. And also, just as shorthand, the brackets that I put around melatonin and GnRH, that just means concentration. So concentration of those hormones. So what's happening during anestrus, during winter? Well, our concentration of melatonin is wrong color there, sorry, is very high because in response to more darkness, less light, the pineal gland will release more melatonin. So if concentrations of melatonin are high, then concentrations of GnRH, which is inhibited by high melatonin, will be, you got it, low. If GnRH secretion or concentration is low, that means that FSH and more importantly LH secretion will also be low. Those are necessary for gonadal function. So gonadal function is low. And by that I mean cyclicity of ability to ovulate, form a CL, all of that. Okay, so what's the dominant ovarian structure during this time? Well, not really any, because there's so much melatonin that FSH is being, suppressed. There's not very large follicles growing. There's no CLs. Ovarian structure that we are concerned about, none, really. Yes, there can be small follicles, but they're not significant. What's our ovarian steroid? Not really any, because you need for follicles to grow larger to secrete estradiol, and you need for them to ovulate and luteinize to produce progesterone, and those are the ovarian steroids that we're talking about here. So, none. All right, let's go on to vernal transition. In the springtime, we are transitioning now. Day length is getting longer, more light is being perceived, so less melatonin. So melatonin is decreasing. That's my shorthand for decreasing, is a down arrow, an ing. Increasing will be an up arrow, an ing. GnRH. What's happening here? Well, melatonin is decreasing. That means that GnRH concentrations will be increasing. Gonadal function. If GnRH is increasing, gonadal function, you can almost think of it as like it's warming up. It is preparing for its busy season. So gonadal function is increasing. Ovarian structure, since melatonin is decreasing, we're going to see more FSH. LH is still being pretty well suppressed, but we are seeing more FSH, which means that follicle sizes will become larger and larger. If we were like checking these mares, we would see every time they're not going to keep those tiny follicles. So follicle growth, follicle growth. No CLs yet, though. Remember that. Ovarian steroid. Follicles are growing larger. They can produce estradiol, which I've shorthanded here as E2. Great. Let's go on to ovulatory. This is when the photoperiod is longest. This is what we detailed in the beginning of the video. Melatonin concentration is at its lowest because there is the longest day length, most hours of light during this time. That means that GnRH concentrations are high. What does that tell us? That means that GnRH is no longer being strongly inhibited by melatonin. which means it is expressing its trophic effect on the cells of the gonadotroph cells of the anterior lobe of the pituitary, so LH and FSH are being released. Those are both necessary for gonadal function, so gonadal function is high. The ovarian structures, since both FSH and LH are being released, follicles can mature to dominance, and they can ovulate, and they can luteinize. So we're going to have follicles and corpus luteums. That's a little messy, sorry about that. Corpus luteums, lutea. The ovarian steroid, which is produced, estradiol produced by the follicles, progesterone produced by the CLs. Progesterone here is P4. All right, now we just have one left. And the one left here is, okay. I apologize if the colors don't match up. But it's still orange. So now we have our day length is decreasing again. This is the fall. So melatonin is going to be increasing. The eye is perceiving less light than it did during the summer. Concentration of GnRH then is then decreasing because this melatonin, which the levels of they're rising, is going to inhibit GnRH release. So decreasing. Gonadal function, you got it, easy, it's decreasing because we have less GnRH. What does that mean about the ovarian structures is, well, we're not fully in anestrus yet. So we're still going to have some follicles that they're not their tiny little anestrus size. They're not insignificant, but they are receding. So the follicles per wave are getting smaller and smaller. They're not ovulating though. They are regressing each time. So follicles, follicle recession. And the ovarian steroid being produced, well, the follicles are still growing to a large enough size to produce estradiol. It's just then they go into atresia. They do not ovulate. So we still have estradiol is the dominant ovarian steroid. All right, so here you have a summary, basically, of what happens to the mare throughout the year. And this really comes down to the amount of light that she perceives. A lot of times in industry, this will be manipulated by, it's called putting mares under lights. And there is a host of beneficial effects from that, one of them being to hasten them into their ovulatory period so that they can be bred. I hope this video has been helpful in explaining the cyclicity of the mare throughout the year. Not all animals are like the mare. Know this. For example, the sheep is quite opposite, where high levels of melatonin will stimulate gonadal function. So the horse is a special case. All right, happy studying. We'll see you guys later. Bye.